Hello everyone, dear friends. This is Nikita with you again, and we continue our challenging journey of mastering the updated RealGUIDE. We will be learning how to create surgical templates there. And I have to say we're already getting into some pretty complex cases. We're moving from simple to complex, and today we'll be talking about full arch work during immediate tooth extraction. We'll go over one of the ways you can do this, how you can implement it. In general, it will be interesting, and if you want to study with us in person, offline, please check out the links in the description. All in all, it will be interesting. We continue after a small transfer. Let's move on. So we are continuing to work with you on our rather interesting case. Today on our agenda is the lower jaw, and we are going to do a total procedure involving multiple tooth extractions with immediate implantation. So how do you handle such cases? I want to say right away that there are two main approaches to doing this work. The simplest and most reliable one is the method we'll be using today. Today, we will be making several guides. This is a kind of technique that we call one guide, one stage. First, we will make a tooth-supported guide for pin fixation, and then using these fixation pins, the main surgical guide will be attached after the teeth are removed. We'll discuss this in more detail when we get to the modeling stage, how the stages of the operation are planned, and how all of this is implemented from a surgical perspective. So there are other types of guides as well, for example, a sectional guide, which we will probably discuss a bit later. How are these guides made and what are they used for? But as I've already mentioned, there are as many opinions about their appropriateness as there are people. Some people perform these procedures only using sectional guides, but most often sectional guides are a rather lengthy process that unfortunately requires more time, which is not always available, and also demands greater manual skills from the surgeon. That's why today we look at a simpler yet effective option. One guide, one stage. All right, let's get started. Now, let's go ahead and click on matching. We click on matching, and now we'll align using artificial intelligence. Yes. Even though the teeth can't really be called intact, most likely. But the good thing is that the enamel is preserved, and when the enamel is intact on the teeth, and accordingly it shows up well on the CT scan with no interference, the artificial intelligence does an excellent job. We double check the alignment on all the slices, and as you can see, let me zoom in a bit, we can see that everything is going quite well. We click, hello. That's it. Remember how long it took us to get to this stage when we had a radiopaque template and then a dentalus jaw? If only everything were that simple. We click, next step. Now we need to construct the CBR plane. Again, without going into too much detail about what that is, we click assist. Here I already had the CBR plane constructed because this was actually our working project. But overall, it only took a few seconds. We click, next step, and now let's trace the nerves. What I like about this program is that this artificial intelligence module really does help with the work. In other words, it's not just a module for the sake of having a modulite. Really did trace the nerves for us in 5 seconds. That's great. You can never have too much time saved. We definitely make it a point to carefully and thoroughly double check the entire process at every step, just to make absolutely sure that everything matches up perfectly as intended. By doing this, we can confidently ensure that there are no discrepancies, and as a result, everything worked out exactly as we had planned, with no unexpected issues. Now, it's clear that there is some dental alveolar deformation present here that is tilted and crowded. So modeling a future structure, I'm referring to a prosthetic one based on them, isn't ideal. Well, actually, not even a prosthetic, but more of an output shape. So if you see a situation like this, it's best to create a new WAXA. We'll talk again in a moment about how to do all of this. Let's click on Create Wax Up. All of these teeth that we want to implant, in our case, we are also planning a full mouth restoration. We select from the 6th tooth to the 6th tooth. Again, we choose the library because that's important. If this is your first time here, you might wonder why you need to select the library. Because if you choose a different library, some widgets won't work correctly. I don't know what that's related to. Click OK. And now we need to position these teeth in the correct places. By the way, if you, like me, are perhaps just a little unsure about how to position the teeth, for example, let's say you're a surgeon and, you know, if you have some issues with this, with positioning the teeth, for example, you don't know what to use as a reference point, right? Whether it's the midline or the antagonists or how to build everything in general, there are some great anatomical landmarks, for example, like the mental foramen. So we recall normal human anatomy, which states that the exit of the mental foramen in most cases is projected between the 4th and 5th teeth. Accordingly, we mentally draw a line like this. Here we have the 4th tooth somewhere, here are the 5th and 6th. Basically, we're on the right track, so we can go ahead and click. And this is what we have. Again, I'll repeat, at this stage we just needed to understand where to position the shafts. And here we encounter a problem. If we leave it like this, yes, here we have the contour of the ridge, but the teeth are still a bit tilted. We can, once again, use the tool, just as we did before, making it possible for us to proceed with our work as intended, and gently tilt them more towards the vestibular side in a controlled manner. All right, good. Once again, I want to emphasize that I'm not claiming any kind of brilliant tooth arrangement here. It's just important for me to have a general idea of where to place the implants, nothing more. Because the actual arrangement, the way it will turn out in the oral cavity, if it's not a detachable template, will depend solely on how the implants are actually positioned. Because what we plan is, of course, all well and good, but the way the implants are actually positioned and how they are actually situated will set the new rules for the new framework, which will then be made to fit the construction, to fit the wax up. So for now, just to make things easier both for ourselves and for our colleagues who will take over this case later, I mean the prosthodontists and technicians, we are roughly sketching things out just to get an idea of where the screw channels will emerge. So we click. And of course, we have this kind of layering, one thing on top of another. To keep this from getting in the way, we can simply open all of this up. Or, by the way, we can actually, I don't think I've shown this tool yet, use something like this, which allows us to adjust the transparency. And you can see that it's become a bit more transparent, so to speak. There you go. Now, let's just proceed as if we're doing a case of the all-on-6 type. The only thing is, I just noticed, by the way, I'm doing this work together with you in real time, just so you know. My horizontal alignment is a bit off, although, again, that's a debatable point. Why? Because, look, if you pay attention to natural teeth that you can't trust because of crowding, deformation, and so on. So basically, here it is the horizon line, or more precisely, the occlusal plane is taking shape, and you can see that our wax up is kind of tilted. But if you pay attention to the body of the mandible, to the rami, you'll notice that if you also position it perpendicularly, you can see that we've more or less set it in the correct position. Okay, but these are all details that should really be addressed a bit earlier in the process. Right now, I'll repeat, we're basically salvaging the situation by at least making some kind of wax up, because with the deformed teeth and what's currently in the oral cavity, it's not really feasible to set things up properly. Okay, now let's talk about the arrangement in an all-on-6 type set. If in the previous case we talked about the arrangement, about the all-on-4 type of placement, and in this case it's all-on-6. With all-on-6 we try to position them well. There are different variations. There's the V2V method. That is, the implants are first placed at an angle like this, then at an angle like that, and then the central implants are placed straight. The classic all-on-6 approach means that all 6 implants are placed, if not exactly parallel, then as parallel to each other as possible. That's exactly what we're going to aim for now. To position the implant, well, let's press 4-2. If I realize that I'm running out of time, I'll probably place them myself and then show you the result, like in the previous video. But for now, let's, first choose a different system. Well, for example, 3D. And by the way, yes, regarding this 3D system, it's not an implant manufacturer, this 3D system. And actually, it's not even a system. There really isn't such a thing. This system doesn't exist. And this thing, 3D, is kind of, how should I put it more precisely? It's a set of various implant sizes. You see here there's 3.75, 3.8, 3.95, 3.11, 3.125, and so on and so forth. Why do you need this thing? Because if you can't find the implant system that you want to use, you use this 3D library and simply select what you need by trial and error. For example, as far as I know, the RealGUIDE doesn't have the Dentium library system. Again, I don't know the reason why it's not there. Well, it's just not there. That's all. What to do? For example, the most common Dentium sizes are 4x8, 4x10, 4x12, or 4.5x8, 4.5x10, 4.5x12. And you just take, for example, an implant, let's say a 4x10, which is available in the Dentium catalog, and you place that implant. Or, for instance, you could take a 4x12. Well, actually, 4x12 is a bit too much, so let's go with 4x10. You can also choose multi-units here. In this case, they will be straight because everything is on 6. And basically, we try to position this whole setup in a more or less proper way. Right now, our implant is tilted. Let's just hide this thing altogether. And let's hide this one too. Let me lift the veil of mystery a bit. In this case, we'll be working with a bone there. We'll try to position the implants in a more or less proper way. Basically, I like this setup. Actually, we could probably even use a slightly larger implant here. Let's do that. Let's put in a 4x12. Okay. And now let's take a 3.2 implant. Let's do this. I'll hit apply now and show you what happens. As you can see, our implant didn't come out very well. And here in the program, there's a cool, neat feature. What's the essence of it? What's the advantage of it? The advantage is that instead of having to manually adjust the angle to get it just right or trying to set it parallel by hand, you can simply right-click on the implant you want to align, and there's a button here called Set the Axis Parallel to. That is, you can program each set the axis to be parallel to another, and here, since we only have one implant, the 4.2 installed so far, you click this button, and I click this button, and now my implant is completely parallel. In the next steps, I'll show you another cool feature. Also, what else should you keep in mind here? Ideally, the platforms of the implants should be placed at the same level. Will we be able to do that now? I don't know. If we can't, well, that's not good. There you go. Usually the classic all-on-4 approach involves positioning the implants like this, 2, 2, 4, 4, 6, 6. Whether we'll be able to do that or not, honestly, I don't know, because I'm working on this case together with you right now in real time, so to speak. I've chosen the 4-4 implant, and now I'm trying to align everything accordingly. But is this really the 4th implant I have here? I don't know. And you can see that my implants are not parallel. But to be honest, well, it doesn't always work out that way with the bone, because the bone is not uniform. You see it has these kinds of curves and so on and so forth. So it's not always possible to place the implants parallel to each other. And that's exactly why multi-units are needed to compensate for this difference in angles. That's normal because, well, nobody in real life, I don't know, does all the work perfectly parallel to each other, just absolutely parallel. That almost never happens. That's why multi-units were created in the first place. But if you have straight multi-units, then as a rule, well, let's say, again, I don't know the exact numbers 100%, but generally straight multi-units can compensate for about 15 degrees between each other. Why am I telling you all this? It would seem that I am pouring water, but in fact it is not so. The thing is, for example, like in my case, I've just placed an implant and it's not parallel, because if I were to make it parallel right now, what would happen? It wouldn't fit very well in terms of the bone and all that sort of thing. Although, for example, if I make it 4x10 now, which is generally acceptable for this kind of work, so if I make it 4x10, it will, in all likelihood, most likely end up coming out in the tuberosity. That's not very good. So we tilt it a little bit and check again according to the bone. Here it's pressing a little against the lingual cortical plate, so we move it into the spongy layer. If you don't understand what I'm talking about, please review the theory. I warned you that we would be coming back to it. There you go. And now, why was I talking about the multi-units? Let's say you place the implant like this. How do you measure the angle between implants? Previously, in older versions of RealGUIDE, you actually had to take these axes, bring them into the same plane, drop a perpendicular here, then here, and measure the angles. Now, there's a button called Show Implant Angles, meaning you can set, well, display the implant angles. And you can set a master implant, and accordingly, you, for example, if we have the count as 4, 2, then that one will be our master implant, meaning the implant from which the measurement is taken. And we see that implant 3, 2 has an angle of 0, because we initially set them to be parallel. And the angle of implant 4, 4 is 5 degrees. 5 degrees, believe me, is nothing at all for multi-units. You can consider them practically parallel, and that's a very good result. Okay, we've played around with that. Now let's move on to implant 3, 4. 3, 4. What do we have here? Here we are going to place it into the root, but this is also quite an illustrative case. Actually, not into the root, sorry, but into the socket. Here it's also not coming out very parallel, so we can align it with 3, 2. Yes, our implant turned out well. By the way, an important point. When you work with these implants in the premolar area, always pay attention to, well, in relation actually to the root. Oh, not to the root, but to the mental foramen. I'm just looking at one thing and talking about another. To the mental foramen, and we can see that there is still quite a distance to the immediate socket. Everything is fine. Now, regarding the positioning like this during immediate extraction at the root, well, in the area of the tooth being removed, that is into the tooth socket, if you've noticed with the previous implants, we tried either to aim for, that is, to mark the implantation in the interradicular septum, or in an area where there are no teeth at all, but now we are placing it exactly into the tooth socket. If we leave it like this, and especially on the axial slice, you can see that, in fact, the tooth socket is wider than the implant itself. So if you leave it this way, you'll end up in a not very good situation. When you start drilling, you realize that your drill isn't even touching the bone. You'll be placing the implant, and the implant will just be loose in there again, because, well, the socket is wider than the implant itself. It's very simple. So once again, we go here to implant planning, change, and our task now is simply to choose an implant that's a little bit wider. Specifically, if here, for example, we are selecting dentium, then, well, let's try a 4.5 by 10 and see how it fits. Overall, it fits in pretty well. Click on it. Here, I've turned off the sleeves because they interfere with visualization. Yes, it's probably worth saying out loud that the program, of course, automatically suggests which sleeve to choose. To disable this, you need to click Unassign. Why am I turning off the sleeves? Because I want to see the visualization of the exit into the channel. That is how the channels will exit from here accordingly. How the channel exits will be projected onto the VEXA. Okay, and now let's talk about the sixth tooth. What do we have there? The sixth implant, to be precise. And we can see that, well, there's no way a 10mm implant will fit here. Although, well, let's do it this way just to be safe. 4.5 by 8 is, in principle, a pretty standard size for the distal sections. Let's see what we get here. Yes, we can see that once again the implant is tilted, and with this let's take a look at how the implants are angled here. With the master we set it to 3.2 here, and here we see that we have 8.8 degrees. Again, anything up to 15 degrees, you don't really need to worry about it, because with straight multi-units the fit will be just fine. Well, now, of course, I'll probably get it from the orthopedist that everything should be perfectly straight there and so on and so forth. I'm not arguing that everything should be perfectly straight with a passive fit and all that, but sometimes it's just impossible because of the bone contour or because of how the technician modeled it in WaxLab. There's just nothing you can do about it. That's it. I mean, you can't just place an implant in midair. So here, you know, there's an analogy. It's like a set of scales. On one side, we have surgery, on the other, prosthodontics. And we're always trying to find the balance between surgery and prosthodontics. That is, we need to place the implants so that they are positioned well, both from a surgical standpoint and from a prosthodontic standpoint. Okay, let's click Apply. Now, let's try to parallel them with the fourth one. So let's try to align them with the fourth one. That's it, but I don't really like the angulation of the abutment channel. After all, it projects into the cusp. If we move it distally, then the distal position isn't any better. Well, actually, what would I do here? If this were a real case, first I would load the antagonists and take a look. Let's load them and see that there's nothing there. But on the other hand, ideally, we should be modeling the VEXA for both the upper and lower jaws here. For example, if the patient isn't going to have work done on the upper jaw, we can see that there's still space here to move the sixth tooth. For instance, if you encounter the same situation as I did, where there is space to move the sixth tooth. That is, you can actually see that right now the cusps are projecting, well, right into, I don't know, the palatal part of this palatal cusp. And you just want to move the sixth tooth a little bit by hand. But a small caveat, this isn't entirely accurate, because when the patient bites down, there's some separation and they might move their lower jaw slightly forward into protrusion or in some other way. And this relationship between the antagonists when the patient's mouth is slightly open isn't quite correct. For this, you need two scans, a bite scan and an antagonist scan, to properly assess the situation. That way, it will be accurate. For now, let me show you what to do if you need to make any adjustments, because I'm sure you'll run into the same issue. So here we have the exit points of the channels, and we click on Edit WaxUp. It really annoys me here that the channel exits disappear. If we click on the implant, the channel exits don't show up, and there is a way to do this. You just need to click like this all the way. On all of these implants, we click on the implants, there. Now everything has appeared. Okay, now we shift it a little bit like this. This can also be shifted a bit, and if we need to rotate something, we can click manual selection, choose the tooth we want to move, activate the widget, and as you can see, we rotated it slightly along the axis. Okay, we click next step. And now, of course, it's not perfect, but it's much better than it was. Now our task is to position the fixation pins, and here, well, it's kind of, you could say, a problem, because, well, not exactly a problem, but it's more complicated than in the previous version, because in fact we are going to have two templates here. One will be tooth supported and the other will be the surgical guide placed on top of it. So now we need to go to the Fixation Pins tab. If you are working with the RealGUIDE kit, and these are in fact RealGUIDE drills, then accordingly there are actually there are always 3 pins. That's it. Usually for this type of work, we use exactly 3 pins, and that's more than enough. Again, we choose the locations where they will be positioned in the most optimal way. Here we will be drilling through the mucosa, that is transgingivally. Remember the insertion path, because if the patient has cheeks, you can't always retract them enough to bring in the drill straight, but as a rule you can retract the cheek up to about the 6th tooth. Most often you can drill in this way, and in the anterior region we will also place 1 fixation pin. Let's see where this can be done. Fixation pins should be placed between the roots of the teeth because they must not touch the tooth roots. Here it is placed correctly, but here it was placed poorly, because when you drill through the fixation pin, nothing good will come of it. You'll just damage the root, damage the drill, and so on. You need to look for spots where there are no roots, and accordingly, this is our biggest problem here. That's it. We've placed it while I was talking, and now we have 3 pins, 1, 2, 3, which will in principle handle the load quite well. Finally, I'll say that the biggest problem with this whole situation here is that we have, let me restore the normal transparency and turn off the teeth. I'll turn off the teeth. There. We don't have any information here about the transitional fold. In other words, you can see that part on the pan butt. You can see that the transitional fold can be seen, right? It hasn't been filmed. What does this mean? It means that we don't know if we make a tooth-supported template, whether it will rest on the mucosa or not. That's why, in any case, such procedures need to be performed by separating the mucosa from the bone flap, from the vestibular side, exposing the bone, and working directly on the bone. Accordingly, today we've done a lot of work together. We loaded one thing onto another in Podgruzile and placed the fixation pins. And now, I think it's time to wrap up this lesson. Thank you very much for your attention. Stay with us, share this video, send it to your friends, colleagues, and anyone else who might be interested in RealGUIDE. We will finish this case in the next lesson. Bye-bye.